Good morning or good afternoon, folks. I'm sorry, my wife and I have to be visiting the doctor again for our daughter at 11 this morning, aka Friday, so I can't really come in. And it's not worth it for me to just try to have us up for 1 or 2 hours. So, with that, I'll be out today, but I'll try my best to be back on Monday. Our baby jaundice level is still very, very high, so therefore, we need to take care of that first. Sorry, folks, but if you happen to have your project done, please turn it in sometime before tonight. And if you have a poster or something, just give it to the sub. I'll try to pick it up and grade it on Monday when I'm back. With that, let's begin. So today you are just going to do the note for 10.1 on energy of reaction. And then with that, just do the 10.1 short quiz. So the law of conservation say that energy is conserved, nothing is created or destroyed during a reaction. So if a reaction release energy, that means some of the energy must be taken out of the molecule and released. Or if the reaction absorb energy, that means some of the energy must have come from the surrounding environment or somewhere else. But the total energy in the universe usually is the same. And to break bond, imagine breaking a rubber band. You have to put energy into it to rip it apart. So energy is required to break bond. And when you make a new bond, you're storing that energy in, aka you made a new rubber band. That energy is now stored inside the bond. So it always takes energy to break something, and you get energy when you build it. So imagine stacking up a block of wood. When you knock it, energy is going to be released, and it takes energy to build it up. So it takes energy to build, release energy when you break. Okay. In this reaction, as you can see from the arrow coming in, it is smaller than the arrow coming out. So if the energy that's released is greater than the energy that's taken in, the extra energy has to go to the surrounding. So if I have my MOE pack and I add water to it, the energy in the chemical reaction between the magnesium and the water will release energy, and that energy from the heat pack will go into the food. So when you have an exothermic reaction, the energy leaves the chemical, aka the heat pack, and it goes into something else. In this case, it's the food to make it hotter. Again, exo means to leave or outside. So your X is outside of your life or to exit a building. So when you have a reaction that tends to show energy coming out as calorie or joules of energy, that is an exothermic reaction. So if there's energy coming out after the arrow, it is an exothermic reaction. And if there's energy coming in before the arrow, it is an endothermic reaction. So when you have an exothermic reaction, heat leaves the chemical and it goes to the surrounding. So everything in the surrounding feels hotter. So if I have a beaker of chemical reacting with each other, the beaker will get hotter because the heat is leaving the chemical, going into the beaker and the surrounding air. As you can see again, the arrow going in is smaller than the arrow going out. So if there's more energy out than in, total is heat is leaving. And therefore it is an exothermic reaction. Okay. How do you know it's an exothermic reaction? Again, the total energy at the end is more than the energy it takes to break the bond. So exothermic will have a bigger energy out than the energy in. aka if you see from where the start is, the bottom of the reaction will be lower than the start. Endo, enter, means in, so the energy that you have going in is smaller than the energy you have going out. So if I have an endothermic reaction like an emergency ice pack, that chemical that reacts in that emergency ice pack will absorb the heat from the surrounding, aka my leg, my ankle, or somewhere else, and that object will feel cold, but the chemical itself is actually gaining energy. So everything else surrounding it that it touches, like your hand, your leg, your wrist, will feel colder. But again, please know that the actual chemical reaction is taking in heat. So it's gaining heat, and everything else surrounding it is getting colder. So if I have an endothermic reaction, the beaker will feel colder because your hand is losing heat to the chemical inside. Okay? So you have an endothermic reaction, you see the energy go in before the arrow. So again, if you have energy before the reaction is complete, that is an endothermic reaction. So again, if you have an endothermic reaction, everything surrounding it feels cooler because the heat is going into the chemical from the surrounding things. And you know it's endothermic because energy in, it is smaller than the energy out. So where you start will be lower than where you finish. Again, exothermic means the heat in the reaction is leaving, and so surrounding gets hotter. Endo means heat from the surrounding is going in. Therefore, the surrounding, the beaker, the glass container, the air is going to feel cooler. So when you have an endothermic reaction, all of the heat is going into the chemical. When you have an exothermic reaction, all of the heat is leaving the chemical. So it feels hot because the heat is leaving it, and it feels cold and endothermic because it's sucking heat into it. Okay, so just thinking a reaction in which the temperature increased, well, guess what? That chemical is increasing temperature because it's getting heat into it. So that's an endothermic reaction. But everything else surrounding it is going to feel cooler, even though the chemical is gaining. So in this case, I have energy going in before the reaction. That's also endothermic. So anything that has endothermic usually means that heat is going in before the arrow, and the surrounding is going to get cooler, but the chemical itself, the temperature might increase. Just an example there. And this is just another two picture of what we saw as endo and exothermic reaction. Additional example. So an exothermic reaction is the chemical getting colder, and the answer is yes, but the surrounding, you feel heat because it is leaving the chemical to go to your hand, to go to the beaker, to go to the thermometer. Endothermic reaction feels cold, but the heat is actually going inside the chemical, so the chemical itself is getting hotter, but the beaker that is holding it, or the glass container that's holding it, is colder. So if I have an emergency ice pack, again, the chemical is actually getting hotter inside that ice pack, but everything else that's touching that ice pack, the air, your body, is going to get cooler, so your flesh will cool down quickly, preventing inflammation or damage. So how does the law of conservation apply to any chemical reaction? The total energy is the same for the whole universe. Some energy has to come in from the outside to go inside an endothermic reaction, and some energy from the chemical has to leave and go back into the universe and everywhere else in an exothermic reaction. And so with that, all you have to do is a 10.1 homework quiz. There's no major math or anything. I will actually teach you the math that's required for this chapter on Monday. Hopefully everything goes well. But with that, have a good day and have a wonderful weekend. I wish you and your family great health and peace.